Hello everyone. In today's video, we're going to be solving this quartic equation. And this quartic equation has a leading coefficient of 2, unlike most quartics you see which have leading coefficients of 1. We're going to be factoring it out just so it's easier, but you can solve this any other method. We're going to be using Ferrari's method. The reason we factor out is so we don't have to deal with square roots, like the square root of 2 or like 9 over square root of 2 times 2. So I would recommend factoring it out. If you don't want to, that's your decision. I'll pause the video if you want to solve it, but let's dive right into it. Let's begin. So 2x to the power 4 minus 9 over 2x cubed plus 7x squared minus 9 over 2x plus 1. And if anyone recognizes, there's two ways you can solve this. All you gotta do is look for the pattern. It's kind of symmetrical, kind of like a mountain. And that's my clue for this. If you can figure out the clue, answer it in the comments. Just answer what the clue is. Whoever gets it right, I'll like your comment and I'll pin it to the top. And just for reference, we wrote the 2 here, but just to keep the algebra clean and have everything organized and not messy, we're not going to write it until the very end, until we have our final answer. So remember that we have a 2 which is outside of the factor, but we're not going to write it till the very end, so everything stays clean. Now let's do our next step. So x to the power 4 minus 9 over 2x cubed equals minus 7x squared plus 9 over 2x minus 1. And now this is A, this is the middle, and we gotta find B. So we know that 2AB equals negative 9 over 2x cubed. 2x squared times B equals negative 9 over 2x cubed. These two cancel out. We get B equals negative 9 over 4x. So let's write that down now. X to the power 4 minus 9 over 2x cubed plus 81 over 16x squared. Same thing to the right side. 81 over 16x squared minus 7x squared plus 9 over 2x minus 1. Now anyone who knows the Ferrari method knows what this is going to be leading to. So this factors out to x squared minus 9 over 4x, square root 9 over 4x squared equals, so let's use your calculators. 7 times 16 would give us 112, and 81 minus 112 is negative 31. So that's negative 31 over 16. So close, could have been negative 2. The answer to this, plus 9 over 2x minus 1. Now we're going to add a constant. You can call this constant anything, z, u, you call it p, o, but we're going to call it lambda, just because I like lambdas. Anyone who gets the joke from physics can tell, but I like lambdas personally, so I'm going to use lambda. So x squared minus 9 over 4x. And most people who do the Ferrari method use lambda too, plus a constant squared equals a squared. This is going to be a. This portion is going to be a. This is going to be b. A squared is just this. So that's going to give us negative 31 over 16 plus 9 over 2x minus 1 plus 2ab. So x squared minus 9 over 4x b lambda. Set that back to 2 plus b squared. So now let's write this down. We got x squared minus 9 over 4x plus lambda squared equals minus 31 over 16 plus 9 over 2x minus 1 plus 2x squared minus, remember the lambda, 2x squared lambda minus, these two cancel out, 9 lambda over 2x plus lambda squared. Now what we're going to do is group this together so we can get in format of A, B, and C. And I'll show you what that is exactly right now. So we get x squared minus 9 over 4x plus lambda squared equals, so let's factor out x squared here. We get 2 lambda a horrible looking lambda, minus 31 over 16, a minus 9 over 2x. We factor out 9 over 2 just so everything looks cleaner. And that's going to give us lambda minus 1 plus lambda squared minus 1. Now, just to explain the logic, I did this in my last video too, but I'm going to quickly touch on it here. We're going to use the discriminant, so b squared minus 4ac equals 0, and we're going to use this because if discriminant equals 0, there's one root. Or sometimes there might be a degenerate case, it might be a constant. So if there's one root or a constant, so if it's, let's say, 7, or if it's like a factored form of a perfect square, or let's say if it's just 8x, as long as it's one root, um, we can write it as a perfect square. If it's a, c, or abc, we can write it as a perfect square. So that's why we're using discriminant. If you want a deeper explanation, you can go to my other video of solving quartic equations, and you'll get a deeper explanation to this. I just touched on it here so anyone who's new can understand. So now we get lambda minus 1 squared minus 4a, and then c lambda squared minus 1. So now there's going to be three roots here, as you can see. But instead of solving the three roots, let's just use one root and call it a day. So we could either factor it all out, use a cubic formula, use synthetic division, and get that one root, or get those three roots, or we can use a smart factoring trick and get the one root. Because out of these three roots, we can use any one, and we'll get to the final answer. The answer will be the same for all of them. So we can factor, and we'll get to the final answer. But instead, let's just find that one root and not have to worry about the hassle for three roots. Nonetheless, all of them will lead to the same place. So you can use any one of the three roots. But let's use the easiest one. So let's factor out lambda minus 1. We get lambda minus 1 squared. Oh no, the square is gone now. Minus 4 2 lambda minus 31 over 16. And remember, this is lambda plus 1, lambda minus 1. Difference of squares. So now all we have left is lambda plus 1 equals 0. So now using the zero product property, we know lambda equals 1, right? Lambda equals 1. So now let's sub that into our original engineered equation. So I'm going to zoom out just so I can see it properly. X squared minus 9 over 4x plus 1 squared equals x squared. 2 times 1 is 2. 2 minus 31 over 16. 1 minus 1 is 0, so that's 0. And 1 squared minus 1 is also 0. So this is all we have. Now x squared minus 9 over 4x plus 1 squared equals 32 minus 31 is 1. So now we get 1 x squared over 16. Now we're going to use the difference of squares to factor this. And we get x squared minus 9 over 4x plus 1 squared minus x squared over 16 equals 0. Now we're going to actually get into the form of the difference of squares. So x squared minus 9 over 4x plus 1 minus x over 4 squared equals 0. And anyone who knows basic algebra knows what to do now. X squared minus 9 over 4x minus x over 4 plus 1. X squared minus 9 over 4x plus x over 4 plus 1. And don't forget about the 2 that we originally factored out. We have to factor that in too. But let's simplify this for now. We get x squared minus 9 plus x, because minus 9 minus x, over 4, oh, minus 9, oh, minus 9 plus 1, minus 9 plus 1. which is just 10. So minus 9 plus 1, so minus 10 over 4x plus 1. Then here we get x squared minus 9 minus 1, which is, well, what is going on with me? I'm getting confused on the easiest things. Okay, x squared minus 9 plus 1, or 9 minus 1, 9 is mine. So that's going to be minus 8 over 4x. I'm sorry, I was getting confused with those most simple things. I don't know what happened to me there. 9, yeah, wait. So now let's factor in the 2 again. Remember that original 2? Let's factor that back in. Do you remember this original 2 we had right here? We're going to factor back in this 2. We're going to factor back in now. So now we get 2x squared minus, with anyone who can do this, 20 over 4 is 5, so 5x plus 2, and then we get x squared minus 2x plus 1 equals 0. And we know what this becomes. So we first, let's do this, 2x squared, let's zoom in a little bit. Let's make this a bit neat. 2x squared minus 5x plus 2, x minus 1 squared equals 0. So we know one root is 1 to this equation. And let's solve this. Let's just factor out the 2 again just to solve it. We didn't really need to factor this in to find the actual roots because the roots are going to be the same. But to get it to the actual equation, we do. So let's say you were instructed to go back to the original equation. So go from the original equation to factored form back to the original equation. You would need to factor in the 2 to get to the original equation. But just find the roots, you only need it. So factor back out, just so we can get the proper answer. We get x squared. Actually, that's going to be more difficult. Quadratic formula, I guess. This is a quadratic formula. Over 2. We get x equals negative 5, that's 5, plus minus square root of b squared, so 25 minus 4 times 416 over 4. So x equals 25 minus 16, 3, so 5 plus 3, 4, and x equals 5 minus 3. So this is going to be 1 over 2, this is going to be 2, right? Yeah. So now the final solutions of 1, 2, and 3, because we have 1, it's going to be 2, 1 over 2, and 1. Thank you for watching. If you have any questions, let me know in the comments. And one trick question, or one additional question for any enthusiastic math enthusiasts: how else would you solve this? So there's Ferrari's method, what added skills, but what number could you divide this entire equation by to make this significantly easier? It's sort of like a mountain, I can say. There's one peak, and it goes up and it goes down. Kind of like a quadratic function. That's the quick question for anyone who wants to solve it. But thank you so much for watching. These are how many steps. If I feel threatened about how many steps this really took, or might be intimidated as a fitting word, don't worry, it's just patterns. And once you recognize those patterns, this becomes significantly easier. Have a good day. Peace out.